Hello and welcome to our wind analysis video. My name is Fraser and together with Wahid and Peter, we explored the Footscray redevelopment proposal and how the wind interacts with the large multi-level buildings. So let's get right into the video. We hope you enjoy.
So our site is at the corner of Buckley Street and Nicholson Street, the central of Footscray. This master planning done initially by F2 Architects in Melbourne. So we think that there is a bit of an issue with the wind similar to Docklands. So we've done the following test. So where did Docklands go wrong? Back in 1989, the said government put out a plan outlining its preferred development model for Docklands. The model was a low to medium density European style development. But however, when the Jeff Kennedy took over, they threw out this plan and then they privatized it and gave the plan to, or the project to developers. A few years after the project's been built, the Docklands completed, the state government in the city council found out that the project was a failure. Normally, when you're designing, the engineer is suggesting that you should do a wind test for pedestrian. For example, Canada and some of European countries, they got this requirement to do the wind test for pedestrian. However, it is not in Victoria, but that was the reason that the Docklands been failed and it's very windy. The last two slides that we looked at the live wind analysis of Docklands from the 24th, 25th and 26th of October. As you can see, the second row, it shows how windy the area is.
Moving forward, we have identified three key areas that we want to focus on. Firstly, we will explore the effects the height of the building can have. Secondly, voids in various shapes and sizes will be deducted from the mass. And finally, we will explore whether or not sharp edges and corners have a greater effect on the wind. Our hypothesis is that the height won't affect the wind disruption too much from a street level. However, we believe large voids and corners that direct the wind will be most advantageous in achieving our end goal.
Using TideFlow, we were able to simulate the flow of particles along a wind path. The wind path is set by creating a vector in the direction of wind flow, in this case from north to south. Particles are then randomly generated to flow along the path at set velocity and speed. As particles collide with an object and deviate from the path, they get smaller and change colour from green to red. The turbulent flow is assessed as it exits the southern side of the proposal. The existing conditions show dense particles as they pass through, which would cause heavier turbulent air for the user at street level on the southern side of the facade.
A few moments later.
Our 9 iterations explored this simulation through our 3 modifications we set to qualitatively determine geometry with wind as its primary design driver. The results were fairly consistent with small changes through voids and height. Visibly positive results were found in the edge treatments and spacing of the buildings. In these instances, we could see that the turbulent flow of particles was reduced, with the size and scale of these particles also consistent. Our final massing utilises aspects of all 3 of our modifications to reduce the turbulent wind flow to the south of the proposal. The building's heights were varied and spaced out more generously, with beveled and contoured edge treatment and larger voids to reduce the displacement that occurred at these sharp angles. The final renders show how our massing fits within the Footscray context. The organic nature of the mullion treatment and mass as a whole demonstrates what large-scale developments could look like if wind was a mandatory design factor in municipal planning, an aspect that was clearly overlooked in the Docklands master plan.
That concludes our presentation. We hope you have enjoyed.